Okay, folks, I wanted to give a little bit of a review at the end of the Blue Planet for you that sort of covers the geology of Australia. Now, again, I could talk for months about this topic, but this is a favorite slide of mine because it puts together some of the important bits. What I think is so fascinating from a geological point of view is that we look here with the colors are coded over here on the right with age. So the red stuff is the really old shit. So some of the oldest rocks on Earth are found in the Gawler Craton, in the middle of South Australia, the Yilgarn of Western Australia, and the world famous Pilbara. And that those are separated by some other younger terrains, and then in between there's nothing but dirt. God knows what's in between there, right? We've never seen the rocks under there. But there's two areas in particular that I was going to speak to you about, not because the others aren't all fascinating, but because the Pilbara has some interesting rocks, and I went on a field trip there, and we spent a lot of time here in the Lachlan Fold Belt. I wanted to talk about that with you. So let's talk about first the Pilbara. And notice how the Pilbara is sitting here. It's very old rocks. Notice more than 2.5 billion years old. There's bits and pieces of rock in there that are definitely 3.2, 3.4, 3.5 billion years old. Some of the oldest stuff on Earth. The oldest zircons on Earth that were found in a sedimentary rock were found in the Yilgarn. So that's a really neat story in itself. And maybe I should do a snippet on that. But that's not the topic of today. The topic today is up in the Pilbara, which is an interesting and fascinating area. And let me show you some things about it. So one of the things that's quite interesting is that this is what we call the Greenstone Belt. And a Greenstone Belt is a bunch of really old rocks. They only happen in the Archean, where we have green rocks, which have been slightly altered to green, pretty much basaltic rocks that have been slightly cooked up to be chloride bearing, which makes them green. You hear they're green. And those are filled with plutons of granite, which we spoke about granites, you know granites. And you can look here at the sort of cartoon of how this happens, is you have big blobs of granite stuff coming in, and this makes a bunch of more mafic altered stuff cemented together by granite. These granites are large, batholithic things. They have a lower density than oceanic crust, and so this is the stuff that made the cratons, or the shields of the crust, not get subducted. So when we look around the Earth and we see the Archean rocks in Canada, Western Australia, South Africa, Russia, these rocks are there because they're buoyant, and everywhere else where there's young stuff, the young stuff is sitting on top of this. This is the shield upon which we float. And it's really quite fascinating, and this allows us to see back into the past. So here we can see here that one of the things that the Pilbara is famous for is some of the best and highest grade iron deposits on Earth. So when people talk about the Hamersley Basin and how we're a huge exporter of iron oxide for making steel with, it's from the Pilbara. The Yilgarn, on the other hand, is one of the world's great gold provinces. We've mined more gold from the Yilgarn than anywhere else on Earth except for South Africa. I'm not talking about that, I'm talking about the Pilbara. And the Pilbara really is gorgeous, and I recommend you go there. And one of the places you go to when you're there is Marble Bar. And this is a picture of Marble Bar, and you can go swimming there, and you can hang out there. And the rocks right here are what it's named for, and of course, they're not marble. Marble is recrystallized limestones, so it's all calcium carbonate. This is chert, really ancient SiO2 with some coloring in it that gives it the beautiful colors. And here we have a rainbow and a swimming hole, and this is Marble Bar. If you look around in that area, you see that it's dominated by iron oxide deposits. These layered sediments here, which are a whole interesting topic in themselves, but at a time in Earth's history, iron was precipitating as oxide like crazy out of the oceans and putting these layers of iron-rich rocks, which we of course call BIF, BIF, which stands for Banded Iron Formation, which is this material is, and this is the stuff that we're mining as fast as we can to ship off to make steel. You can see how beautifully layered it is. So these are sedimentary rocks laid down on the ocean floor. And in between the really high-grade stuff, there's lots of bits that have too much silica in them, so they're not mined. So we made a national park out of this thing, which is called Croagini, which I really recommend you go to. If you look here, you'll see that, look at that beautiful flat layered stuff. This is where a river has cut into these beautiful iron oxides. And if you walk down, you find yourselves following the river through this amazing little skinny gorge. And these are some third-year ANU geology students from 10 years ago. They're all off working somewhere as geologists. But notice how this river is slowly, slowly cutting through here. Layers, 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 each one older than the other. And every other layer is super rich in iron. And as that iron is oxidized, we get a coating of the orange color on that. So here we are in some of the swimming holes, and then there's the banded iron formation. And here's one of my former PhD students, Nick Tailby, standing on the nice, beautiful layers of iron oxide. You can see that. You can see that it's a sedimentary, iron-rich rock. And you can see how it's coming off in slabs. So this is a perfect iron-rich sedimentary rock. There are some more students doing our little walk through here. We camped here at Croagini. It was hot as blazes up above. There was like 40 degrees up top. But down here, it was lovely 22 degrees. Absolutely. So there's something I may have talked to you about before, but I just want to reiterate it because I think it's a cool topic, is that if you go as a geologist to Australia, one of the places you have to go in the middle of nowhere, West Australia, is this Hamelin Pool. And the reason is because this area here is called Shark's Bay, probably because this looks like the head of a shark. But if you look here and come here, you drive all this way to see these bloody things, these funny little lumps of goo. These are called stromatolites. These are blue-green algae mats that form here from the ocean. And they're just precipitating out like that. And they don't look like much, and they kind of stink. They're just the most primitive stuff on Earth. When I was a student, we only called them blue-green algae, but that wasn't complicated enough, so we now call them cyanobacteria. Either way, this is the first form of life on Earth. We have evidence of these things back in the Archean 3.5 billion years ago, and they're still here, but we rarely see them. Why are they there? They're there because if you look at the blue of the ocean here, and you look at here, there's a sandbar cutting it off, it means that this bay is restricted from mixing with the rest of the ocean. So within this bay, as it evaporates, it becomes more and more saline. And it's not that the blue-green algae prefers the saline, highly saline waters, it's that everything that eats blue-green algae is dead because they can't stand the high salinity. So this is one of the only places on Earth where we can go look at blue-green algae. And as boring as it is to see them, it's rather interesting to see something that was living for billions and billions of years, way before we were even thought of. And if you look around a bit more, and I can skip that, and you go to the right outcrops in the Pilbara, which we did on our field trip, you see these layered things here called stromatolites. These are 3.4 billion year old stromatolites, not far from where we have the living stromatolites. And that tells us a lot about this is shallow water environment, right? Marine system, we talk about there being a continuum, right? The idea that the present is the key to the past, and that everything that happens today was happening in the past. This is exactly like modern rocks. And we know these are stromatolites because we can cut those fresh ones up and see these same mats. These are mats of communities of algae that form this way. And with that, I will stop. Thank you very much.